Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem having been chosen from the book Modern Physics by Kenneth S. Crane. Okay, as usual we first come to its statement. Okay, what is the momentum of a proton moving at a speed of v equal to 0.86 c, where c is the speed of light? Okay, what is the momentum of a proton moving at a speed of v equal to 0.86 c, that is c is speed of light. This is a relativistic speed because this speed has been expressed in terms of c, speed of light. It means that out of 100 units of speed of light, 86 units have been involved in this speed. Okay, 86 out of 100. Okay, anyhow we move to its solution. In this dear students, in solution of this problem we will use this table in which speed of light is given c equal to 2.998 into 10 raised to the power 8 meter per second. Moreover, proton mass mp, where p is written as a subscript of m, is equal to 1.007276 atomic mass unit u. This alternatively becomes equal to 938.3 million electron volt over c square. Okay, we will use this second expression. Okay, and on the basis of this we try to solve our problem, which is quite simple. Okay, we know that the relativistic momentum for a particle of mass m moving with velocity v is given as p equal to mv over 1 minus v square over c square. Okay, equation number 1. In this equation we will just put the values which have been provided in this problem. Here value of v is given as 0.86 c, speed of light, and mass of proton, that is here it is being denoted by simply m, while in table it was denoted by mp, that is mass of proton, equal to 938.3 million electron volt over c square in equation number 1. Okay, we will use these two values in equation number 1 and we will get the answer. Okay, p is equal to mv over 1 minus v c square. This becomes equal to, in place of m or mp, that is mass of proton, we have written 938.3 million electron volt over c square, into v is given in terms of c, that is v is equal to 0.86 c over 1 minus v square over c square. In place of v we have used 0.86 c, and in place of c we have just used c. We have not replaced c by its alternate value, that is 2.998 into 10 raised to the power 8 meter per second. Okay, because here c will be cancelled out with c, and we do not need to put the value of c in terms of meter per second. Okay, so this expression next, in the next step, this situation takes the form as 806.938 million electron volt over c. Okay, because dear students, 1c will be cancelled out with 1c, and after multiplying 938.3 with 0.86 we will get 806.938, okay, million electron volt over c. Okay, 1c has been cancelled. Moreover, within the under root it will become 1 minus 0.7396. okay, because c square will be cancelled out with c square, and square of 0.86 will be equal to 0.7396. okay, in the next step numerator is the same, no change in the numerator, while denominator becomes under root 0.2604. okay, in the next step no change in the numerator, while in the denominator the value of under root 0.2604, which is equal to 0.51, has been used. Okay, in the next step our solution has become equal to 1582.23 million electron volt over c. Okay, this is the momentum of proton, and this is the end of our problem. Till next video, Allah Hafiz.